All right, so let's go ahead and get started. So the last couple of times we've gone through different versions of SQL, what you can do with it, right? So again, there is in the couple of slide sets that are out there. So last time we kind of went through the SQL document as opposed to the slides. So there's some additional capabilities that are listed in the slide sets, but I just want you to know that they're there, right? But the material that we would potentially put on the exam is just off of what we covered, right? So the specific things that were in slide set number 1 of SQL and the handout called SQL Doc that's out there that we went through last time. But again, there's less used or less frequently used components that are in the rest of these slides. So take a look at it just so that you know that it's available, but I'm not going to specifically ask you anything related to that on the exam. Right. So we want to talk about design at this point. So what I want to point out to you is that the book has, and most textbooks do that, they have made this overly complicated. Yes?
I'm sorry, I have a very unrelated question. Would you like me to hold?
You might as well just, like, you know.
So my question is, on December 1st, my understanding is that we are to turn in an evaluation of our team.
Yes.
I'm hoping that that document will be made available to us tonight.
If not tonight, I will have it for tomorrow.
Sweet. I'll set a reminder. Thank you.
You'll send me a reminder, thank you. Yes.
So following up on that, we're also supposed to turn in all of our documents, correct?
Yes, all of the documents that you have up to this point. So again, this is not the, I'm going to grade this and give you something very specific, but this is to ensure that if you don't turn in enough documents, that we'll have a little chat saying, you really got to step this up, otherwise you're not going to make it, right?
Is there any specific form you want those documents in?
It's up to you. So again, the scenario is that what should you have at this point, right? You should have a complete and a build ERD about what you are going to ultimately deliver, right? There should be a problem statement of what you are working on. So like, what's your definition of success, right? Okay. Given the ERD, the build ERD that you came up with, what is the kinds of screens that you're going to need to do this, right? So what is the technology that you're using, right? So it's more summary types of things at this point rather than all the details. Okay. So for example, we're going to be talking today about the design and the normalization of data, stuff like that. So I'm not expecting you to rush and go, oh, I have to have this all done by the 1st. Right? Again, you are planning this based off of what you need to ultimately develop. Right? So I'm more interested in, at this point, ensuring that the documents that you have are going to be something that you can compare to say, have I delivered what I need to out of the project? Because what should happen at this point, Mark? What is your favorite word? Traceability, right? So you should be able to trace the complete ERD back to the problem that you are describing, the total environment. You should be able to create a build ERD based off of what your specifications, right? So you need a specification list, right, of what you're coming up with, because otherwise how do we know that your build matches to what you have to accomplish, right? So I'm looking for a lot of the preliminary components related to that. So you should be able to, out of that, like I said, here's what my screens are going to look like, here's how I expect the user to interact with this, here is the data that we need to either store or be able to retrieve in some way. Based off of what we have, you may have a preliminary design, right? Not every team is gonna have the exact same level of component. And again, the key piece of this is ultimately testing it. So how are you going to go through and validate? So what data are you gonna have to be able to put in to then get the results back out? Right? And like I said, then kind of you should have a plan of how you're going to build it, so what technologies you're going to use. And I am leaving it as open as I can in terms of the format, because a lot of you work someplace that has some type of template that you may have seen or you may have used, right? And to make you do it in some other one is just going to slow you down. So I'm more interested in, do you have the content of what you need to have rather than what's the format that it's actually going to come in. Okay, that make sense?
Yeah.
Okay, you're okay with that?
That's great, thank you.
Because I know that's going to be your next thing. So what do we have to have? Well, I mean, it's, I want everything that you have up to this point to tell me how well you're progressing as a team, so then I should be able to match that back to what you've been telling me about your statuses. Right? Oh, we completed this, this, and this. Well, how come you didn't turn that in then? So stuff like that. Or, look, we did all this work, and how come you never mentioned this? Right, so it can work both ways. All right, so Cooper, anything else you want to, like, you know?
I hope you had a good week last week.
No, last week was
I hope you're having a good week this week.
I'll find out soon.
When, have you decided the date that we'll do the presentation?
Yes, so whatever the 18th or whatever it is, so the day of the final, right? So basically 2 weeks from tonight, right, is the last class, right? So 11th, something like that. So on the 11th, you will take the final, and on the day that the scheduled final is, someone from your team needs to present. So your whole team does not have to be here, right? So that you have the distance learning crowd and all that kind of stuff, right? So again, you're dividing up the work whatever way you want. So a lot of times everybody comes in, but it's not a requirement that everybody do that.
So if I'm understanding right, the final is the 11th and the 18th is the presentations?
Yes.
And only one person has to present it.
It's up to you. Right? You need a minimum of one,
Okay.
right? Okay, but again, right, it's whoever's doing the presentation, or if all of you are doing it, right, you are dividing whatever work that is up. So if you are, say you are presenting for your team, then everybody else should be doing other stuff to make up the, or equivalent the time that it's going to take you to do the presentation. Right. But yes, so one or more people from your team presents, right? So it's, the presentation is basically go through and show some of your documents, right? So I would expect a complete ERD, to build ERD, here's, right, so kind of walk through, right? It is not a walk through every line, but just so you can see what the other teams did with the same, right? Because you all got the same project, right? See how they differentiate from each other, right? See what kind of screens that you came up with, how did you interpret the things, right? And stuff like that. So walk through kind of screenshots of or displays of the different documents that you ultimately created, right? And then after that, then you run through the demo of what you've actually built. Right? So you need to be able to add data, and you have to be able to change the data, and you have to buy things, and right, all the things that you are accounting for, right? And then obviously, scenario of, so how did it go? What did you learn from it? What would you do differently? So what went right, what went wrong, kind of things like that. So I'll put together a list and put that out there for you to, so you know exactly what I'm looking for in the presentation. Okay?
And then for submission, we'll have our documentation. For our actual project might be somewhat difficult to like build on your own machine, is that okay? Or at least it's involved.
When I remind me again.
So in terms of what we're submitting, so like our application or what we put together, it might be difficult, let's say, for you to build on your own machine, like there's a few
Mhm.
hoops you have to jump through. Is that okay? Like we demo it, we give you the, show you how it works, we walk you through that, and then we give you the documentation. And,
I mean, obviously, the preference is that I get to actually then mess around with it, right? But that's part of what the demo is about is, right, you go, hey, how about trying this? And then you talk about how nice the weather is outside or something. Or you just go and do it and go, see, it works.
Our company doesn't support that.
So I will put together the list of that, and right. Now certainly it would be better if I have access to something, but we know that based on the technology, you might not. Right. But in your turn-in, what I would expect you to have would be, right, if I don't have access to it, or in case it fails during the access, you should have screenshots of all of the different actions and stuff, so that, right, so because I've had that before where, oh, here's the project, here's how you access it, and here's what you do, and I type it in and it doesn't work. I'm not in the business to figure out how to fix what you've given me. Right, so kind of the screenshots of every action that you can possibly do and the functionality associated with it would kind of help make sure that we don't have a problem. Okay? All right, so what happens 2 weeks?
Final.
I know.
Taco party, no.
Right? Okay, and then, so the week after that, like I said, I think it's the 18th, so it would be the following Tuesday. Someone from your team, or as many people as you want from your team, will do the presentation and then the walkthrough of the project. All right, any other questions? Okay, Cooper, are we okay? Okay, you're sending me an email, right?
Tomorrow morning at 9 a.m.
All right, just making sure. All right, so I've started to say before Cooper derailed us with this very thoughtful question, okay, is the textbooks that we have typically make it way more complicated than it is. So when we walk through the different slides here, we'll kind of refer to what they're talking about, but I'm going to tell you how we really do it, which is way simpler than what they talk about, right? So they're trying to do this whole formal thing. Here's exactly how all of this works, right? But we'll try and, right, because my mind I can only do things in like simple terms. So I'll try and put it in the simple terms for you guys to do. Yeah. Okay, so when we talk about relational database design, right, this again is where people get hung up because we have the entity relationship diagrams and we're mapping them. So which one are we mapping? The bill, right? Because that's the one, right? That's the one that you have determined you need. Right? So what as we said when we talked about ERDs in the first place, what is our biggest problem that we have with ERDs in general? Right? It's we only create, in the real world, we only create the builds. And we create builds for each individual project, not looking at how all of the builds interact with each other. So what we end up with is when we get to this point, we design things that don't need to be designed. We build things that have already been built, but we build them in a different way. And ultimately, it causes us a lot of extra administrative work, right? And problems that we'll talk about than if we did it correctly. Right? So again, the best way to do this is doing a complete ERD and then do what? What do we know about the builds? It is a maximum of the same, and 99.999998% of the time, it's a subset. And if I keep my complete, and on top of the complete, I overlay every single build that I do to know what's been built and what has not been built, I'm going to ensure that I come up with my new build and I go out and look, and 9 out of the 10 things have already been built. I know that I only have to account for one more. If I don't know what everybody else has built, I can go out and I might build, I know of 3 of them, I build an additional 7. And it duplicates stuff that is already out there, and I do it in a different way. Okay? So, books typically don't talk about a complete ERD because no one does them. Why don't we do them? Because of the cost and the time. But if you have one, it's going to save way more time and effort than it took to actually put it together. Okay. So the goals that we have during this whole mapping process is, right, we have to preserve all of the stuff. Right? So we need to preserve the data. We have to preserve the data types that we have, being the entities. We have to build or preserve all of the relationships. We have to preserve all of the cardinalities, right? Once you have identified what all of the things are on the build ERD, we have to ensure that that's ultimately what we're going to do. Okay? So, one of the things that we have on the next line there is maintain the constraints to the extent possible. So, we have relational model cannot preserve all constraints. So, for example, we have a max cardinality ratio such as 1 to 10, right? So that's our kind of cardinality, right? Okay. So depending on the type of relational database management system that you are using, you may be able to put in that constraint, or you might not. So you may, right? So again, you have to make decisions during this process of what you're going to include inside the database management system and what ones you're going to have to programmatically inside your application ultimately decide is in or out. Okay. Okay. We also talked about the whole exhaustive classifications, right? So that was the different subtypes, right, that you have. So is it exhaustive? Is it overlapping? Is it disjoint, right? So you had the 4 types that we dealt with on the exam, right? So do you need that? And if you do, what are the types that you're going to put out there? And ultimately, are you enforcing it, or are you letting the database management system enforce that? Okay. Now, the next one it says is to minimize null values. Okay? And what again was a null value? Yeah, it's unknown, or it exists, but I just don't know what it is, right? It could be, I will determine this later, right? Right? But it's not safe. So why would we say that we want to minimize the number of null values? Because a lot of times, what do we do in our databases? That we just talked about in the last couple of classes. We query the data to come up with results. Right? And you can't very well match on null values. Right? Because it could mean anything, because it's an unknown. Right? Where normally we're asked of what is the count of the number of students that live in the city of Dearborn? Right? It's not, give me a count of the people that we don't know where they live. I mean, so sometimes we look at it, but in general, right, you're not doing those kinds of comparisons. All right, so they go through a whole series of steps here, right? But again, we can narrow this down to something that's very simple. So the first one is the mapping of regular entity types. So what does that mean? You're looking at the build ERD and looking and saying, oh, look, there's this entity that I have on my build, so I need to build it. All right, what a shocking concept there, right? So, for each regular strong entity, so we had the idea of a strong entity and a weak entity. What's a strong entity? It's something that, right, you have, it represents the entire domain, it's not relying on anything else, right? It is truly defining the overarching domain of values, right? So what's a weak entity? It's something that it can't be there unless a strong entity exists. Right? So the example that we'll see when we talk about the weak entities in here is a dependent of an employee. Right? You can't have any dependents if there is no associated employee. Okay, what about here at school? Right? You don't have, or an account doesn't exist until you're a student. Right? So account would be the weak entity because it can't exist without a strong entity. Right? So they're saying, right? They say start with the strong ones and then do a step later on that is going to do the weak ones. Well, what do we do in reality? You just look at the build and say, we don't care whether it's a strong or a weak. We know that we have to build it, so, right, combine them in a single step. Okay? So, for each strong entity, create a relation or a table that includes all of the attributes of that entity. So again, are you creating all of them? Only the ones that are on the build. Right? Because again, the complete may have a whole bunch of attributes that exist. You could get data about, you could record that data, but you don't need it at this point. Okay, so let's ask a question a different way. If, when you are creating the build, what do you have to take into account? How do you know what goes into the build?
Whatever addresses the requirements.
That is part number one. Right? So part number one, as Mark pointed out to us, is you look through all of the requirements. Okay? So I need from this system, I need to be able to create a transcript for students. So you go through and say, okay, so what's on a transcript? So I have the student data, I have data about the department that they are, or the college that they are enrolled in. I need the courses that they took. I need the grades that they got. I need to know the semester they took it, right? So I can go through that whole list. Okay, so that satisfies the current requirement. Right? But what else might I want to look at when I create the bill? What are future things that I know I potentially need? Right? Because how many times do you want to go through adding or changing your relations or your databases? You don't, right? So while I'm in and messing around and creating the ones that I have, I need to look ahead and say, yes, I know what I currently need, but what do I know in the future is not, well, I don't know if we're going to do this, but I'm pretty certain. Right? So we are on a project right now where we're adding probably about 50 different attributes, not for the current project, but ones that I know that are going to happen in the next 2 years with probably 90% certainty. Why? Because I'm pulling ahead the work. I'm already doing this. I'm in the programs that are accessing it, right? So that's going to bring the data in earlier, allowing obviously analytics to happen against that if we need to do something with it, right? And that makes the future projects cheaper because we don't have to go and make those changes, right? If it's an 80% chance, well, we start thinking about, do we really want to do it or not? If it's 50%, the answer is no. Right? So again, different companies have different ranges associated with that. All right, so we have to figure out what the mapping of it is for the relation. We have to define what our primary key is going to be. And again, what was the scenario for once I had my relation laid out? Right, so what should I get from you guys? Here is the relation that we identified. Here's the data that's going to be on it. Here is the candidate keys that we came up with. Here is the primary key that we selected. And here is why this is what we selected. Right? So what's the reason that you did it? Not, oh, it sounded good. Right? So you should have a justification for everything that you laid. Yes?
In practice, are those reasons for justification in implementation-specific documentation, or do they also find their way into data dictionaries?
Data dictionaries as well?
Both?
Absolutely. Okay. Because again, what's the purpose of the data dictionary? If I want to know anything about this particular thing, it's there. Okay? So we actually go through and say, here is why we selected this one, and if I go to a different one, this is a candidate key, but it was not selected because. So we kind of have why and why not's in there. So great question, Cooper. Okay. As we talked about, you can have composite keys, right? So we need to review that because again, what is the scenario for your primary key? You want to keep it to one value if you can. Right? Obviously, if I have a relation that I'm building that is the relationship of a many to many, obviously I have to have a composite for that because we're using at least at a minimum the combination of the two primary keys. You can't create one out of that. Right? But again, you're looking at it and you're justifying what is the key and why that is in place. So, we create relations, employee, department, and project in relational schema, right? And we use the social security number, the department number, and the project number as the primary keys, right? And, right? So again, if this was our build ERD off of this, what do we know? We're going to have to create employee, right? And it's got a number of attributes associated with it. We have department, right? And what do we know about the relationship between employee and department? There is two different relationships that we have to account for and build, right? So we have to account for both of those, right? And we know that we're going to have employee to project, department to project, we have the dependents, right? And we have the one-to-one for the employees supervising other employees, right? So when you start looking at this, what do we know? What's our first one, right? Is they're saying look at the strong entities, and all of them are strong entities except for dependent. Okay, so there's step number 2 is mapping of the weak entities, right? So you have to identify which is the associated strong entity that's associated with that, okay? So again, we have the foreign keys associated with that to link them together, right? Because again, you cannot have a weak entity without a strong one, right? And so again, where does the foreign key go, though? It depends. Right? Okay, so at a scenario of the student and the account, right? It's a one-to-one because you only have one account as a per student, right? And which one do you access most often? Student, right? So since I'm already likely to have a student, I'm probably going to put the key on the student or the strong one, right? Because I'm already going to have that data. Okay, now what about this one where we had the dependent? It's a one-to-many, and we said that we always put the key on the many side because there's only one, right? So in that case, it's on the weak entity side, not on the strong entity side, because of the cardinality that we have. So the point I'm trying to make is there's no one rule that is going to say it specifically goes on the strong or it goes on the weak. You have to look at what is the cardinality that you have associated with it and how's it map. Right? That's why we do this mapping exercise. Okay. So again, if I'm looking at this, right, so if I want to find all of the dependents, I need the primary key of the employee, and then I'm going to get all of the associated dependent keys, and that's going to be my universe of a set of dependents that are for a given employee. So what do? I have to go to the employee, right, to get that data, and then I can use that to go get dependents unless the primary key is exactly the same. I already have it. Okay. But, for example, if I only know the employee's name, I may look it up. I have to select from a list because we can have the names being the same, then use the employee number to go get the dependents, right? So again, a key thing that we talked about way back on day one of all of this was what is going to make you most effective from an IT perspective, or actually from a business perspective as well, is you understand what data you have and how the company you're at works with it. If you know that, this is going to be really easy. If you don't understand this, you have a high potential you're going to get it wrong, and therefore, once you start getting it in front of the customer and they're saying, that's not the way that we're going to use it, you have to then go back and change a whole bunch of stuff. And changing stuff is never easy, and it's very time consuming. So, again, our example associated with this is the fact that our weak entities are always going to have the dependency that we're going to have on it, so the relationship's going to be there. And again, I need to use that as being able to process it. Okay, so step number 3 is the binary one-to-one relationship. So in this case, it's the employee supervising other employees. Okay, so it's as simple as that. Okay. So again, we don't actually have very many of these. Okay. So the most common one is going to be your binary relationship, but we do have a number, so you will encounter these, but they're certainly a very small percentage of the overall total. Okay, so for each binary relationship, right, we have to identify the different relations and how we're going to process those. So again, what did we know when we talked about this in terms of the SQL? We had to give them different names, right? So when we had employee, we called them, I think they actually called them in their example, S&T is the versions, right? And because you had to compare the value in one versus the value in the other, right? So in the different fields. Okay, so you have to understand what they're going to be. So we have the idea of the foreign key, right? Or two relations approach, right? So again, we say that S and we have a foreign key in that, and it's the primary key of the other, right? So again, it's, what do we have? We have supervisor SSN, and that's the non-key value, and it's a foreign key to the social security number of the actual employee who is the supervisor, right? So that's kind of the typical approach that we use, is you mapping a field that has the primary key and it's a foreign key in the same table. Okay, does that make sense? So, and again, what can foreign keys have null values? Yes. Right? So we know that. The primary keys obviously cannot. Okay. Right. So the merged relation, so we have one relation, so an alternative mapping of this is merging the entity types and relationship into a single relation, right? Okay, and this is typically when they are total. What do they mean by this, total? It means there's no nulls. Okay. And then the cross-reference or relationship one, we have 3 relations. How many times do we want to make 3 relations? Never. Right? So we want to keep it very simple. So it's typically either option 1 or option 2, right? And 1 and 2 are actually pretty similar, right? But again, it's what do you know? Right? If we look back to the original thing, it was minimize the number of nulls. We don't really care. It's how are you using that data to ensure that what you're doing is only correct. Okay. And in a sense, 1 and 2 are very close, because if I want to make one relation, I can actually define it as 2 in my SQL, and fake it out that I'm doing. So I can, right? So I can build it as one, treat it as two in my SQL, so I get the best of both worlds. But again, it comes down to what data you have, what way do you want to lay it out, and what way are you going to access it, and what changes are you going to have as you do it. Okay. Okay. Step number 4 is the one-to-many relationships. Right. So it's a binary one-to-many. Identify the relation that's participating. Right, as we said, where do we put the key? We put the key on the many side, right? So they put a whole bunch of words out here that just tell you to do that. Okay. Okay. So in our relationship works for and supervision, right? So works for, we include the primary key, which is the department number, right, as the foreign key in the employee relation. So again, we just give it a different name. Okay, in our many-to-many, right? So again, what does many-to-many mean? There is no way that I can put all of the foreign keys on one side or the other. Right? So what do? We put and create an entirely new database or a table that's made up of at a minimum, the primary keys, so it's always a composite primary key, of both relations. Then, if that is not unique, I have to add a third. Okay. So our example that we had for that was you as a student. You take a course. You get a grade. If we only had you taking a course and getting a grade, that would be good enough. The fact that you can take a course multiple times, sometimes people withdraw. Cooper, I know you don't, but the rest of us, especially me, I'm not as smart as you. I have more W's on my transcript than I have grades, I think. I was to cut them all up. Okay. Okay. But what else do we need to know to do a transcript? You have to know what semester it was taken in. Right? So I need to know what was the student, what course did they take, what semester was it taken in, and what grade did they get? I'm matching up the student and the course. So student ID identifies you as a student, but course identifies the course that you took. Right? So those together, but that wasn't unique enough, so we had to add a third. So again, looking at our relationship, right, the build DRD, that should already tell us when we have to do that. Okay. So if we go back to our example here, okay. So, right, what do we know about this one? What about between employee and projects? Right? Okay. So, employee can work on multiple projects, the project can have multiple employees, right? So I know for sure, at a minimum, I'm gonna have the project number and the employee social security number as a composite key that I have to build on. Now, I have hours off of that, right? So that is the number of hours in what period? Over the life of the project? If it is, then that's all I need. If it's, I need the number of hours that were worked on this project in a given month, in a given year, right? This gets back to Mark's idea of, I have to understand the requirements. Because if I have to know a time period, right, I may have to have not only hours, but the start date of the period and the end date of the period. I might need the year, I might need the month, right? Whatever that happens to be, right, to make that a unique value. Okay, what's the, since we have this up, what is the dashed thing around, dashed oval around the number of employees? What's that signifying?
It's calculated field.
Calculated, right? So it's a derived field. Right? So what do you have to decide as a designer? Am I actually going to store this? Or when I need it, am I going to calculate it? What would drive me to doing one version versus the other?
Changes frequently, it may not make sense to store it.
Okay, so change, frequency of change. That's one. What else? The amount of time it takes to calculate. Right? If it takes me 5 minutes on the clock to calculate it every time, and I'm going to be calculating this thousands of times a day, it doesn't make sense to do that. Right? So again, this gets back to what we talked about of you have to understand how this data is being used to help you design it effectively. Right, so again, they have the line on here of making sure that, again, off of your build DRD, you should have all of the attributes that are associated with that composite combination. Okay, what about the one back here for start date on manages? So this one is a one-to-one relationship, and I have an attribute off of that. What the heck am I going to do with that one? Am I going to make a separate table or relation for this manages so I can hang the start date off of it? Maybe. Depends how many that you have, right? Because again, your field for, if I say employee manages a department, right? And I have 80,000 employees and I have 10,000 departments, that means I have 70,000 null entries. Do I care? Probably not. But again, you have to evaluate it and you have to understand how it's used. Okay? So, where am I going to put this? So, what happens on a one-to-one? The key value can be on either side. And so if I have employee manages a department, which side am I going to put it on?
Foreign key should be on department.
Foreign key would be on the department. So why? Because that's the correct answer, but we know that that's never going to be what I'm going to accept for.
Because I can imagine that a department may not have a manager at all every single instant. So a null value there would be good. Also, if we're gonna hang the start date off employee, then we can probably expect the majority of those values to be null, and there'll be fewer nulls if we hang it off department.
Yeah, right. So again, it's, right, in general, your department is always going to have a manager. Right? So the likelihood I'm gonna have nulls on the department side if I put the employee ID of who's managing it and the start date of when they started managing it is probably going to be really small, the number of nulls, if any. If I flip it to the employee side, like you said, right, I have 10,000 apartments, but 80,000 employees, that means I'm gonna have 70,000 of them that are null. That makes no sense, right? So again, what is the data you have? Minimize the number of null instances. So that's kind of what we're talking about when we say minimize the nulls, because I'm putting it on either side associated with that. Okay, so what do we know so far? You know what entities that you're going to have. I've identified a primary key for each of those. I know that I need a set of attributes for those. All of the ones that I'm going to have. I need to look at what is the cardinality they have. So that's why it's important to make sure that your cardinality on the ERD is correct. Okay. And then I am looking to say, out of the 1-to-1, it can go on either side, but what side makes the most sense to minimize the number of nulls. If I have a 1-to-many, it always goes on the many side. Okay. And then if I have a many-to-many, it's always going to be a separate relation that I'm going to build, composite primary key, attributes if I have any, right, to manage that work. If it's a unary relationship, right, I am typically going to put the foreign key into the table, right, and just reference that to back to the original table using the SQL associated with that. Okay, so multi-valued attributes. So what's the idea of multi-valued attributes? Means I have, for a given attribute, I can have multiple values, right? So we say student and phone numbers. Cooper's probably got like 10 different phone numbers.
Yeah, if you include the area code.
So the point is that, right, there are times where we have to, if we're going to use multi-valued, I either have to identify a set number of attribute fields and call it phone 1, phone 2, phone 3, something very exciting like that. Or we do what? We build a new relation that is going to tie Cooper with his phone numbers. So I built another, right? So what's our common theme that we're seeing so far in our design? We keep adding stuff. Okay. Now, they have this way down at number 6, but in reality, you are typically working your way through what? Each of the entities. And in real life, we look at an entity and deal with everything about that entity that we can. Then we step up and say, with that entity, what are the relationships to the other ones? And so we deal with everything with an entity and then move to the next one. Right? Okay. So they lay this all out, but I have yet to be at a place that we did it in the order that they have identified here. even though they say most places do it this way. So I've typically, obviously not worked at places that they talk to about this. Okay, so again, it's a new relation. Why? Because, right, what happens if I make the phone number attributes that there's only 5 of them? You're going to get to the person who has 6. And then what do? Go back and add a new column. Oh, well, then there's a person who's got 7. Right? And what happens then if one of the entries, so Cooper went from 6 phones to 5 phones? Do I have to shift them all over and do stuff to, to know which ones? It just gets really messy. Right? So keeping it simple, putting it as a new relation. It's got the key value. I select all of the ones we have, then select off of some other criteria, then to which one you use. Something like that is going to make life obviously easier. All right, so the idea that they have on this one is a n-ary relationship. So this is where we have more than 2. Okay. So again, you're going to create a whole new relationship to handle this one, right? And what do we know if it's a 3-way? It's going to have at least a minimum of 3 primary key values in the composite primary key of the new relation. If it's a 4-way relation, I know that it's a minimum of 4. If it's 5, you're going to... Okay. Okay, so they give you lots of examples of these, right? I have never encountered one where we have gone above 3. It just gets too complicated to manage. Yeah,
What's an example of 3?
we'll see one. And it's not sucky dirt example. I can't spell supply. Okay, so in our supply example, so they're creating, right? They're creating a new relationship called supply. And it's going to be made up of the combination of the supplier name, part number, and the project name, right? So those are the 3 things that are going to cause this. An example. So if we go down to our example here, right? We have a supplier is supplying a given part for a project. So we have 3s, but once you start getting out to 4 and 5, it just gets pretty messy. Deal with that. Okay? Because now you have to deal with how many suppliers do I have supplying how many parts to a given project, right? And trying to manage different combinations gets hard. So that's the example of a ternary, which is the 3. And again, if I kind of look back to the project right here, right, we can, right, this is what we had kind of so far. We had the employee, we have department, locations, project, right? What didn't we see? And so, okay, this is the quiz question of the day. What is wrong with what they have just shown us? It should be right smack in front of you. We have talked about this multiple times. What do we have here for our entities? How many do we have? Okay. And where should we find all of these? We should find them on the build ERD. Right? We should find this on the complete ERD. Right? So if this has not appeared already as a ternary relationship in your ERDs, you're not going off and saying, I'm now going to magically create this. This should already be something that you have discovered when you created the ERDs in the first place. Does that make sense? Right? Because this isn't a made-up relationship that you just come up with as you're analyzing this. It needs to already exist as part of your analysis of what is the entities, relationships, and data that you have in your organization to start with. So if you're just figuring it out now, here in this step, you've got a bigger problem. Okay, does that make sense? All right. So again, we are looking at the different relationships. We're identifying the foreign keys that represent the whole thing, right? So again, that supplier, part, and project are all combinations that you have to have all three primary keys together to signify that you have a value for that. And then when you do have something like that, that's three, we have always, in every single case that I've ever come across this, we have had data attributes off of that. So again, in our example here, right, so given a supplier and a part for a project, I want to know the quantity of that part that was supplied for that particular project. Right, so again, you're reading all three of them together. Everybody okay with that? Right, so again, if I toss this out on the exam, you should be able to say, right, this is going to tell me what supplier provided a given part for a given project with this particular quantity. Right? Because it's the primary key of all of them to get that one piece of data. Okay, so if we were to draw that, right? So again, the supplier, project, and part are all individual relations, and to get to the individual quantity field, we needed all three of those. Okay? Right, so again, if we kind of compare the different things in our entity relationship model, we had a entity type, and in our relational model, we ended up with a entity table or a relation. Okay. On a one-to-one or a one-to-many relationship, we needed a foreign key, right? That was telling us that there was a match between those. And again, what do we know about foreign keys? What's going to happen in the database management system? When I insert the data and I have it defined in our DDL as a foreign key, the database management system is automatically going to go to the table that is defining that domain and verifying that it's there, and if it's not, it's going to give you a error, a warning message, something, right? Right? So, and it can be, you can take it as a default, as make it null, right? We saw all kind of different instances of how that would be handled. Okay. So, and when we had a many-to-many, we created a new relation, and it had a minimum of 2 foreign keys, right? So why is it a minimum of 2? because the primary keys in the tables could be composite keys. Right? So, if they're a little bit off in their wording there, that's okay. Okay, so, and again, in the n-ary relationship, right, we have a new relation that we create, and it has as many foreign keys as you have entities that are included in it. The simple attribute is just an attribute on our relation. The composite attributes, right, so again, name is made up of first name, middle name, last name, right? So we have to identify all of the component attributes, right? If I have a multi-valued attribute, we make a new relation associated with that and the foreign key associated with that. Okay? The value set is that data, right? So now that we actually have the data, it becomes the domain. And again, what's the domain in terms of data? All of the possible valid values that you can potentially have. Okay, and then our key attribute, we have a primary or secondary key, right? Again, what's primary? Unique, non-null. Okay. We had candidate keys, which were what?
Unique and non-null.
Unique and non-null, but we didn't select those. But it also includes the one that we did select. Candidate is all of the possible ones that are potentially primary. Okay, what is secondary? Two favorite words? It depends. So if you look at the majority of textbooks, they will talk about secondary keys as being the candidate keys that you didn't select. If you go out in the real world and talk to people about what a secondary key is, it is the keys that you actually are using to search or query into the databases or into your relations. Right? So I could have, for example, as a student, right, in every place that I have worked or the other DBAs that I have dealt with, okay, we would say that name is a secondary key, even though we could have duplicates of the same name, right? Because that's a key that we are searching on or querying into the database as a common way to do it. If you're looking, I could just think, right? If I'm just doing a search in it's kind of an ad hoc thing, and I look at it and use that combination once or something like that to answer a question, we don't call that a secondary key. Secondary key is one that you are using a large percentage of time, right? Not compared to the primary key, but a large number of times in a repeatable process. So Cooper, you had a question?
Yeah, how helpful is it to label things in metadata like a secondary key? I mean, I understand that some stuff is critical, but is it at all helpful to say, oh, this is often something people will use? Or is that sort of a waste of breath?
We don't put it into the metadata, but where do we put it?
Data dictionary?
The dictionary. So I could go to the data dictionary and I could, for example, go to a relation that exists and I click on the tab that says secondary keys and I can see all of the actions that are on a repeatable basis available and used. And I can say, oh, and I've had this, right? Oh, there's already one out there doing exactly what I'm looking for it to do. Because it's in the dictionary. The metadata doesn't always keep that. Because again, a lot of your secondary keys aren't recorded in the metadata as a secondary key. It's the applications or SQL that's written and where they are running that makes it a secondary key. All right, so that's the basis. So again, it's very simple. The thing that you need to remember is literally this page. Right? So entities become, right, so entities on your build ERD become entities that you are going to build in relationships or in your database, right? I'm gonna have one-to-one, one-to-many, or many-to-many, and I have to figure out where the keys are gonna be. It's easy on the many-to-many because it becomes its own separate relation. On a one-to-many, it always goes on the many side. If it's one-to-one, you have to look and say, what am I gonna use it for, and what's the best way to approach it? Right? So in the example that we had for you, if I'm coming in for the student, I'm going to get the account because I'm going to do that way. But if I'm dealing with everything from an account perspective, I may want it the other way because the majority of my work is coming at it from the account. And so I may want it on that side. And for the crazy people who can't decide, you put it on both. Because it's only one field. And it can go on either one. Right? But then now you have to do the extra work associated with that. Okay, so again, if I was to say, what do you need to study and understand for the final, this is the slide right here. If you can walk through this one just like we did a couple of times, right? That's what all the last slides were about, is coming up with that. All right, so we talked about generalization and specialization, and what was that about? That's our hierarchies, right? That's our overlapping, right? And the non-overlapping ones, right? Are you know, completely in it or not, right? So again, we have these, but we don't tend to have lots of them. Okay. So again, why don't we want to have lots? The more relations that you have, the more expensive it is to manage it. Right? So you want to build the ones that you have. Right? Okay. All right. So again, they make a big deal about it. So they have option 8A and 8B and 8C and 8D, right? So we can have all these different attributes and all this other kind of, my head hurts just to think about looking at these slides, right? So we convert each specialization into subclasses and a generalized subclass, superclass, and right then we're going to do one of these options. Let's think about this for a second. Where should I already see this? In what? The ERD, right? I should already know from looking at the ERD whether I need to build this or not. Okay. Now, just because it's on the ERD as a specialization generalization does not mean you build it that way. Why not?
There might be a better way.
Wow, that is so awesomely just. I would consider giving you credit for that just because of the way it sounds, but no. All right, no, but let's think about this practically. Right? Okay, why would we break things up into components or categories of things, right? From a specialization or not? Because we have additional attributes that are unique to that subgroup, right? Because what do you have at the generalized level? All of the attributes that apply to everybody, right? All the things that are underneath it. So that means what's down at the lower levels are things that are unique to one or a subset of the lower level, because if they applied to all of them, you would have moved it already up to the top. So now you have to determine the effort it's going to take to manage this. Right? So an example would be if I have a subgroup, right, or a specialization that has one attribute, it makes 0 sense to create an entire new relation, link it back to the special or the generalization one for one field. I don't care how many nulls I have, right? Move it up to the top. Right? If I have 25 fields that are unique, absolutely I'm going to create one. Right? So again, it's understanding your data. How do you need to set it up? How much work is it going to be to do that? Because again, every extra relation that you have to go and query against to retrieve data and all those joins that we talked about, all takes time. And what do we say about your joins? The maximum number should be like 4 or 5. 5 is really pushing the limits on most database management systems. The more relations you build out here that you need to start joining together, the more effort it's going to take, and your database management system is going to bog down. Right? So what you will see as we work through this is we break it all apart and then we combine stuff together to minimize the number where it makes sense. Okay? So again, what we're trying to do in this one here is say, right, first off, look at your ERD. You should be able to say that I need this generalization specialization. It occurs in the way that we look at the data, but the way I'm going to build it, do I really need to do it that way or not? And we have some instances where it's a combination. There's things that we eliminate at the specialization level because there's, in one instance, there's only 1 or 2 fields. And another one now, on that same level, we have 10 or 20, and we'll make a separate instance of that. Right? So it depends. There is not one recognition. Will it work if you build it out completely? Yes, but it may not work very effectively. All right, so it goes through these different kind of scenarios here, right? So I'm not going to walk through these specifically, right? So you can kind of read through these. I'm not going to ask you about this on the exam, right? What I'm going to ask you on the exam is what we just talked about. How would I look at if I have on a build ERD, a specialization, how would I go looking at what I would define for what I would actually build? And it comes down to what is the number of pieces of data, what are the attributes, how many, how does it apply, right? So again, if I have 4 subgroups, right, or specializations, and there's the same data field across all of those, I'm probably just going to move it up to the top. Right? If I'm going to use that a lot. If I'm not, I may leave it down, right? So again, it's always comes back to you need to understand your data, how's it going to be used, what's populated in it, how often is it going to be used, and all of that is all that upfront work that you have to do. Okay, so we have multiple relations where we have superclasses and subclasses. We have multiple relations where we only have subclasses, right? And we kind of tie those together different ways. We have a single relation and one type attribute. So again, just know that there's different approaches you can take, but keep it simple. That's what we're trying to instill in you guys from a analysis perspective and design perspective. Where we fail a lot of times when you talk to most groups and you go to their data administrators or your database administrators, they have made it too complex. So I have been through multiple redesigns of things because once we built it, it did not work effectively. So you undo all the things that you did. And who wants to do that? Okay, so again, just to get back to our scenario. So what would you say on this one? So we have employee, and we have a job type, and we can have secretary, engineer, or technician. What would you do with this one? If we said, you're in charge.
If there weren't a whole lot of other types of employees.
No, that's it.
Then I'd probably just move them into
What?
Yeah, add an employee type field too.
What? Okay, so you have to remember, right? So this job type here is made up of one of these three at a minimum. Okay? So to Mark's point, I can have all kind of other job types. Right? We have identified three down here, secretary, technician, and engineer, because there is specific data we want about those types. Right? So I could have, right, city planner on here, for example. Right? We just don't want to have any data about a city planner at all that we want to keep track of. Right? Okay. Maybe looking for a new job or something, right? But, okay. But point is that, right, if this is not the full list, right? So remember we talked about your disjoint overlapping, do you have partial or total, right? All those kinds of things. Right? So you have to understand what that is. But when we define these things, we know that we want the typing speed for a secretary, we want a technical grade for a technician, and we want to know the type of engineer. That's what we want to know. Okay. So, what are you going to do with this? If it was me, I would make it all one. Why? There's only one piece of data for each one of these. Yes, it's going to be null, right? So the typing speed is going to be null for everybody unless they are a secretary. But if I want to really build a whole separate relation that's going to have the employee number and a typing speed associated with it, and that's the only thing on it? Probably not. Right? Because if I do this, I now have within my complete database, which is all of the tables associated with it, now I have 3 with minimal pieces of data. Could we do it? Yes. Will you find it that way at some companies? Absolutely. But from an administrative standpoint of managing these, the database management system work to access all of these, making sure they're all tied together and stuff, right? The cost of the null fields on the single database instance is out of whack. So again, right, if we were to use their option of splitting them all up, right, we would actually create all of the separate instances. So, would it work? Yes. Right? And, right, again, in the secretary, you're only going to have the ones that they're actually all secretaries. So this should be a relatively small number compared to all of the employees. I'm not going to have any null values in here at all. But that's okay. Okay. Right? So in option C, right, we just added them at the end, right? So we had the typing speed and the rate on there. Right? Okay. Associated with that. Okay. Of course, they left off the last one, so that's pretty nice of them. So, error on their part. Thank you, book. Okay. All right, so we talked about things like this one, right? So we had individually the car and the truck, and we looked at this and determined that we should have vehicle. Okay. So what do we know about it now? Right, we have the generalization, specialization, right? And where should this appear? In your ERD, right? So again, you should already have thought about this, right? This isn't, oh, we're way into this and now we're going to think about doing this. Your ERD, when you created the complete one, should already have broken this down. Okay? So what's the advantage of doing it in the complete? You've already done all of this work. If you decide that you need it, you have it laid out for what you need and can go build it. And if you do it correctly, all of that is in the data dictionary, and in the data dictionary you always have, if you actually go to build this, because it's not built yet, here's how we would suggest you would do that. Because you've thought about it, right? Do all the work that you can around the things that you have control over. Okay, so again, in our scenario, we would have the car and the truck. Okay, and like we said, then you would go back and change it so that you have the vehicle. Okay? But again, you should already know when you go to build it, looking at the ERDs, what you ultimately want to do with that. Okay. All right, so what about this one? What do you think you would do with this one? What's your little O in the circle mean? Overlapping. Okay.
Put them in the same one again.
You put them in the same one?
Because you can just, if it's overlapping, then it just would be no null.
It's not necessarily true.
Well, overlapping, it may be overlapping. It doesn't have to be.
Well, if it was, like in the case that you had one that was both.
Yeah, if you had both. Right. Right. So again, this one is going to get back to, it depends. Right? Because what do you know at the part level? And we know that, right, it can't be a manufactured part or a purchased part unless the part exists. Every part has a part number and it has a part description. Okay. Now, there's three pieces of data over on the manufactured side, and we have the purchased part, and we have two of them. So again, with this limited number, I would probably just put it all in one. Okay. But it also depends on how many parts you have, what is the, how many null values you're going to have, what is the way that we're going to look at this. Are we going to have to, because again, what happens if they are separate? I have to, if I want to know always know the description when I'm getting this kind of stuff for the majority of the time. It doesn't make sense to go to multiple places. Right? So again, it comes down to what do you know and how does it work?
But let's say there are lot many fields for each of those manufactured part and purchased part.
Yeah, right, that's what we have. We have 3 and 2. So that's what I said. My first inclination, without knowing anything about how this is used, my first thought is combine them all together into one. because I'm gonna have some that are overlapping, as Mark said, so all the data across in that one row or instance is gonna be completely filled, right?
Yeah.
If I had a large percentage of parts that are in both, that's even more reason to combine them together. If I have only 2% of the parts being manufactured and 98 being purchased, I may think otherwise.
So you'll have two tables.
So I might have two.
With the same
Yeah.
part number.
Absolutely, right? So again, how many of each do you have,
Okay.
right? If I put them together, how many nulls are gonna have? What is the way I'm going to access those? Right? So if, again, kind of if I say that I manufactured 80% of the parts and 20 are gonna be purchased, and all of my inquiries from the management team tend to be around the manufactured, I want it all on, combine those two into one and have a separate one for the purchased. Right? So you can do any combination of these that you want, but again, you can't decide for real until you know how it's going to be used and how many that you have of each. Okay? So again, if I go back into the data dictionary, right, I should have, for each one of these things, I should have a estimate of how many of these exist. Why do I need that?
Right.
If I just go and say, oh, great database administrator, I need a part database. The first question is going to be, what data do you tend to put on this? Second question is going to be, how is it going to be used? The third question is going to be, how many instances or how many parts are you going to expect on it? Because all of that is going to drive what the database is going to be. Okay. So as we talk, right, behind the scenes, your database management system is going to have different ways to go out and access that data. Okay. And you as a consumer of that data, you're going to want different ways to access it. So if my access is always going to be a one time, meaning the user is going to come in on a web page and they're going to type in their student number and up's going to pop the student information, I'm going to have a different storage or access technology behind the scenes than if I'm running a whole bunch of stuff where I have to see, okay, I need a list of everybody in this class, I need right, so I'm gathering lots of data at the same time, right? Right? Because, so that comes down to what's your usage. So before I can design this, but then there's a whole separate piece behind this that happens of, now what's the methodology you're using to access this data?
Okay.
So I can have the same structure, so on the next line here, right? So I can look at it and say, okay, I'm gonna have a part database where I'm gonna have the description and I have these flags to say whether they're a manufactured part or a purchased part, right? So I have one or both of them indicators, right? And then I have these specific things associated with those, right? Okay. Now that I have this, behind the scenes, I can have this exact same layout for multiple, right, for each row, but my file system behind the scenes can be structured completely differently to allow faster access one way versus the other. So the first step is define what this looks like. The second step, I can't build it size-wise unless I know exactly how many. And then the third action is, now that I know what the record each row is going to look like, I know how many of them are there. Now it's, what way are you going to access it? Then I can actually go build it. Okay, does that make sense?
Yeah.
Right, so there's
So-
multiple steps.
So the approach that the text has said, that's not the only thing which you have to look for, like, so they have provided some option 8A, B, 8C, so that's not the only thing which you need to look at, you have to also look at the.
Oh, yeah, that is just, what they're talking about at this point, with the steps that they have so far, is what is this row going to look like? That's the only piece that they're really looking at. And what I'm saying is that the way the book describes it doesn't take into account all the things you want to truly consider if you are going to be determining the rows. Because if you don't understand how it's going to be used and how many you have, this gets you pretty close, but this isn't the final version. Okay. All right, so again, they kind of went through and defined what the different options are. So again, it's your 8A, B, C, and so on. Right? Okay. Okay, so again, the mapping of the shared subclasses, right? So multiple inheritance. Okay. Right, so a shared subclass such as a student assistant is a subclass of several classes. This just gets completely messy. If you're trying to have your database management system handle multiple inheritance, it will work, but it will work extremely slow. I have seen this in every textbook that we have ever used in the database systems. I have seen this once in real life. Because when the database management system is trying to manage this, especially when you're doing inserts and updates and all that kind of stuff, right? It has to tie all this stuff together. It just takes too long, right? So there's lots of extra overhead associated with that. So they talk about it in here. Yes, you will find it. You will find it so extremely low amounts that it's good to know it's there, but it's tough to do. Right? So the kind of idea here is, and again, if we look at this, we have the student assistant being in the employee, they're in the student category, right? And then there you have coming down, they're either a research assistant, a teaching assistant, right? Okay, so think about the database management system and the work that has to happen when you insert something into the student assistant. What has to happen? There's a foreign key into the employee. There's a foreign key into the student, right? So that's two updates. So whenever I put something into there, I have to go out and do two foreign key checks. Okay? Then what happens when I go down into the research assistant and the teaching assistant, right? So I'm one of those because those are discrete or disjoint, right? So I now have to come back to the student assistant, right, and manage those, right? So, right? And what do you know about inserting a student assistant? You have to be in one of the ones underneath, so we know that those actions are going to take place. So when you think about it, right, you're doing action after action after action, and they, right? What are you doing while this is all going on? You're staring at the screen. How happy are you staring at a screen? Not very happy. Yeah. Okay. So, they are out there. We tend to know that they exist, but we don't necessarily tie them together from a database perspective. Okay, so again, this is just showing that you can tie some of these things together, right? So in this case, we have, right, a person's and the student or an alumnus, right? We have alumni degrees that we have associated with that, and obviously they can have more of those, right? So again, we just see the different kinds of things that they're laying out here. Okay. Okay, union categories, right? So what was that all about? If I take a union of them, that makes the entire domain of values that we were working with. Right, so you had separate entities, they had their own separate pieces of data that matched, right? So that was the requirement. You had different entities, but they had the exact same data. When you put the union of them together, it's the same set of data, right? Because you are doing the union of them. That's why you have to have the exact same sets of data. What is the likelihood we have the exact same sets of data across multiple things? And we typically don't have that, right? So yes, these exist. You do encounter them, certainly a lot more than the multiple inheritance, but again, they are still relatively rare in the sequence of things. Okay. So again, if we go back to the example that they had in the book, they had a vehicle, you had an owner, and the owner was made up of the person, the company, and the bank, right? Okay. So what was owner going to have on it? It has to have all of those attributes that you had above. Right? Because we got to combine them all together into one. Right? Or we depict it as this, but you have to literally, from an application standpoint, go out to all three places. So that's what we end up doing a lot of times when we have different pieces of data like this. Right? Is yes, we consider the fact that there is an owner. It's in the data dictionary as it's a union of the different types. From an application standpoint, you know that you have to go out and access all three of those, right? So I would ask, are you a person, are you a company, or are you a financial institution? And that would drive me to then ask the question of which one that data we need to do the selection process. Okay. Okay. So again, if we look at this, our owner is going to have an owner ID, and again, it becomes the foreign key to take us back into the various components. Right? Okay. Now, again, what a lot of times we do is, what was a view? It was a temporary area to hold data. Okay. So, what could we do in this instance? Physically, this is the way it would look. I could create a view that would put a total of 9 different data fields after the owner ID, right? A bunch of them are going to be nulls and stuff, right? Okay, but I would have all the owner and all of the data associated with it on the same view. You access that view all day, and right, and until we get enough new people, banks, or companies, right, with owner IDs. We just leave the view in place. What about the integrity of the data? The real data is behind the scenes in the person, the bank, and the company tables. you as the application are referencing, because I know the owner, I'm just going to the owner view to retrieve that. So instead of creating a direct union relationship of just having unionists, right? If it was me, I'd most likely do that. But again, it depends on some of the other factors that we've talked about. So again, a lot of times the database administrators or the data administrators don't think of views in the right way. They're there to help you. Right? They protect the data behind the scenes, so I could be updating stuff. And right, so we have instances where we generate new views 4 or 5 times a day because it's close enough. The likelihood that there's going to be an inquiry at the company for a vehicle that was just purchased today, right, in the next 2 hours after it comes in is pretty small. Okay. So again, it's understanding the data and what constraints that you have around it. Yeah, don't think you're done though. Nice try. All right. Any questions on the mapping? All right. So either you're all asleep or we have to start going faster because we need to get more stuff to put on a file or something. All right. So functional dependencies and normalization. All right. So on this one, again, textbooks love to go into the detail. Okay? And what happens during the determination of functional dependencies and normalization is we break things down. We make more relations. So you've already seen in the first set of slides that we went through and we made new relations, because we had to do it for many to many. We had to create the new relation to handle the many to many relationship and the attributes associated with that. Right? We saw that we had the specialization and generalization. We could separate those out, right? So we can keep creating all of these. Okay? And then after we get that done, then we start looking at this to break it down even more. Okay, so what is this relational design, right? It's grouping of attributes to form good relational schemas, right? So we haven't built anything yet. We're still in that whole design thing, right? We need to understand the 2 levels. Sounds like a great test question, right? Okay, the logical view and the storage view. What's the logical view? This is the view that the user sees. How is the user perceiving this? Right? And then we have the storage level, which is the base relation, which is what did we actually build, right? So a lot of times, especially when you have views that are generating things, or you have applications that are generating them, the users, the end users themselves, don't have a clue how you physically created these. Okay. So my business customer, the only thing that they know is, yeah, we got some DB2 tables in the background and it's a relational database system. They can't name a table. They kind of know some general ones. Yeah, we have a customer. Okay, we have an account, right? So, and they kind of over time know what kind of some of the data would be, but there is, out of the 550 some tables, they can probably, if I ask them, how many do we have? They'd probably say 10. Because that's their view. So that's what we're trying to get at here is we have a business view and we have a physical view. Okay? So our design is concerned mainly with the base relations because that's what we actually have to physically build from the database management system perspective, right? So, what are the criteria for good base relations? Right? So, we'll talk about this and right in terms of what that is. Then we will talk about these normalization process, right? And we have different types of normalization. We call first, second, third. Ooh, right? In reality, we actually can go up to 6 numbered ones. 1, 2, 3, 4, 5, 6. Very nice. Then they found problems with some of those. So you have like this boys cat things, right? So you, in reality, you could probably get up to 10 different iterations of normalization.
Is that third normal form? That's
Yeah. Yeah, right? So, like, I start typing stuff, okay? I already told you I have a problem here, right? So, go back and fix it. Actually, that was just to see if you were actually looking at the slides, but no, that was my fault. That's why I should never put slides together. All right, so point is that there's 10, 12 iterations of these that you could go through, and we do basically 3 in reality. And why do we do 3? Because it catches the majority of things. Okay? Because what is going through all of these? It all takes time, right? And there is typically a relatively small number of people that are database proficient from a design standpoint. Right? So at companies, they're sometimes embedded in the teams themselves. So they get all kind of other jobs to do too. Okay? If you have a central service team that is your data administration and database administration, they could be combined together, right? So in my role, I acted as both. Okay? In different companies I've been at, they've had separate groups, right? So different responsibilities, right? But again, there are so many projects and so many demands, we typically don't have time to do every single one of these things. Okay? So we'll talk about the additional things and things like that. Right? Right? So guideline number 1, informally each row that we have in a relation should represent one entity or relationship instance. Wow, is that like a novel concept? One row represents one instance. Right? So they have lots of words to say that. Okay. But again, we tie things together, right? So you have the foreign keys that will link your relations together and things like that, right? Okay. So it says only foreign keys should be used to refer to other entities, right? And what is the advantage of using foreign keys? The database management system is ensuring the integrity of that data. Right? Okay. Entity and relationship attributes should be kept apart as much as possible. Think that's really true? No. You put it where it makes the most sense. Right? Okay. So, design a schema that can be explained easily by the relation. Right? So again, semantics. Semantics is the meaning. The meaning of the attribute should be easy to interpret. Right? And where should we be able to find all of this stuff? In the data dictionary. Right? Okay, so if we were to look at their company database that they describe in the book, we have the employee, we have the social security number as the primary key, the foreign key at the end for the department number, right? So in there we have the primary key and foreign key, right? Things like that. Okay. 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 Okay, so what might be, if you were to look at this, what would you kind of think that you should do to rearrange this? Think of primary keys. Where do you want primary keys? You want those that kind of as the first entry in your set of data. So, right, I don't want to have to be scanning around to find where the primary key is. Just give me the first thing in the thing, and right, if it's a composite one, it's going to be the first and the second. Right? I have gotten them where they're in the middle and at the end, and right, so just stick with a standard. The standard typically is the first thing you encounter is the primary key. Okay. Okay. All right. So redundant data. Oh, redundant data. Waste storage, update anomalies, insertion, deletion, and modification. So what are they talking about here? So it's easy to understand what waste storage means. If I'm recording these thing twice, obviously I'm using twice as much data storage as I need because it's the same data stored twice. I only need it once, right? So what are the updated anomalies? What's the insertion anomaly? I have to ensure if I have it in two places and I insert something, I have to insert it in both places. Otherwise I have a problem. Same thing with a delete. If I go to delete it, I have to make sure that I delete it in both places. Otherwise, I've only deleted it in one, and now I have to question whether it's really there. And I insert it wrong. I deleted it wrong. What's the real answer? Don't know, right? You have to research a whole bunch of stuff. And what about modification? If you change it in one place, you have to change it in both. And what did you change? Right? Because we typically, in our data, you typically have something to keep track of. Who updated it and when did they last update it? So typically user ID, and it could be a program, application, whatever it is. Right? It doesn't have to be a person, but some ID of who updated it last and what was the date or time that it was updated at, but you don't have a record without going back to that log that we talked about. What was the exact piece of data that changed? Okay, so consider the relation where we have the employee project. So we have employee number, project number, right? The employee name and the project name and the number of hours. So change the name of the project P1 from billing to customer accounting because this update to be made for all of the 100 employees working on the project. Where should I have the project name? Only in the project relation. Right? So I change it once, then everybody gets automatically updated. Okay, so our insertion on this one, right? Can't insert a project unless an employee is assigned to it. That doesn't sound too good, right? Can't insert an employee unless he or she is assigned to a project. That doesn't sound good either. Right? So, what can you look at and tell from this? I've got data in the wrong place. Right? That's all they're really trying to tell you about this. Right? Okay, what about delete? When a project is deleted, it will result in deleting all the employees who work on that project.
Might be okay.
Might be okay, but might not be okay. If an employee is the sole employee on a project, deleting an employee will result in deleting the project. That might be okay too. Not likely, but okay. So again, the idea here is that we just looking at it, we can tell that we have things in the wrong place. Okay? So, we have two relation schemas that clearly are suffering from update anomalies, right? So, again, what's in the first one? Okay. I have department name and the department manager associated with the employee record. That doesn't make any sense. Okay? 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 What about the employee project underneath that one? I have the employee name and the project name and the project location. Right? So none of those make any sense. Okay? So again, as you look at what data should be in there, right? So, why do you think that this possibly happens? We don't think about it ahead of time. We're not really using the ERDs like we should. We're rushing through and we just jam stuff together and say, okay, let's put it out there and we'll fix stuff later. Right? It always causes problems. Okay? Now, what about this one? Right? So we had redundancy over there on the right-hand side because our department name and the department manager social security number appears multiple times. Right? So research appears 4 times and administration appears 3 times. Right? And it's the exact same set of data. And how many times should data appear? Once. Right? So the fact that I have redundant data, right, says we got a problem. Yes?
But foreign keys are always going to be redundant.
True, but what's the purpose of a foreign key?
So that you can store that stuff somewhere else.
So I can store that stuff somewhere else. Because I need that data, and I have to have a way to get there, right? And a foreign key is not the original set of data, right? Because to insert something into the foreign key, it has to be null, meaning there is no instance, or I have to go and find it someplace. So it's an integrity check. Yeah.
Are foreign key integrity checks something the database does intuitively when a foreign key relation is defined?
Yes.
Okay, cool.
Right. So as soon as you say that you have a foreign key that tells the database management system when it looks at the metadata, I have to go to this other one to check. So again, that's why if you have a relation that you build that's got lots of foreign keys on it, and I actually insert data into that, it takes a long time because it has to check every single one of those. Right? So again, down in the bottom one here, the employee name appears multiple times as well as the project name and project location. Right? So just some examples associated with that. Right? Okay, so guideline number 2, design a schema that does not suffer from the anomalies. Gee, we just talked about those, right? And if there are, note them so that we can take them into account. Because again, you have to be able to ensure the integrity of your data. As we said, that is kind of the number one thing that you are responsible to do when you build an application or you build databases, to ensure that the data that is out there is correct 100% of the time. Okay. Guideline 3, so relations should be designed such their rows will have as few null values as possible. Right? Attributes that are null frequently could be placed in separate relations. Right? Okay. So again, this is in general true, but not always. Right? And again, it's going to be what is the true number that you have, because again, you have overhead for every additional relation that you build. The database management system has overhead to manage that can certainly be outweighed of having some extra nulls. So again, it depends. Right, so reasons for nulls, right? It's not applicable or invalid, it's unknown, but it may exist, we just don't happen to know. It's known to exist, but it's unavailable at this point in time, right? Things like that. Okay. So again, our bad designs for relational database result in erroneous results. For different joins that we have what's called lossless joins, used to guarantee meaningful results, right? But again, that now comes back to, remember we talked about inner and outer joins, right? So you had inner, outer, full, right? Which way that you wanted to look at. So again, nulls can play havoc with that. So again, understanding what is the best approach, how is it going to be used, what are people going to be looking at, right, are going to help you do that. Right? Right? So again, that's kind of what number 4 gets us down to, right? We have to satisfy the fact that we want to guarantee meaningful results getting around all the nulls that we have. So a lot of times we have to code for that. Okay. All right, so the other kinds of things that we need to look at are, right, the properties of decomposition, so non-additive or losslessness of the corresponding joins, and we have to preserve the functional dependencies. So again, what's a dependency? They are related in some way, right? And functional dependency means we have a dependency on functionality between those, so we have to account for that. Okay. So the property A up above is really about, we need to ensure that we're going to get correct results 100% of the time. That's all there's really saying. So a lot of words to say that. Okay. And property B is less stringent and may be sacrificed because guess what? Sometimes when we preserve all of our functional dependencies, that means overhead in the process. Because to satisfy functional dependencies, your database management system is managing those. So the more you make the database management system work, the longer it takes for you, the longer it takes for everybody else. You have 20, 30,000 people accessing this all at the same time. Every nanosecond counts, okay, in the overall process. Okay, so functional dependencies are used to specify the formal measures of goodness. Okay? And keys that we use are typically part of that whole process. So we talked about functional dependencies being the foreign keys, right? Things like that that we deal with. And we have constraints, right? So we talked about looking at things, are they in the right range, right? Are we going to do things when we get outside of the range? Okay. So again, we have a set of attributes that determines a set of y. So if you think about it, we have a mapping between a set of inputs and a set of outputs, and it has to be the same and correct every single time that we go through it. So that's all I really try to say in all of this, right, is we have functional dependencies that we define are going to be from real world experiences that we are trying to ultimately manage. So where are you going to find these functional dependencies outlined? In your specifications, right? So part of your job, and that, what's that word again, Mark?
Traceability.
Traceability. I should be able to look through all of these specifications that I have and be able to drive out what I believe are all of the functional dependencies associated with that. Okay. Right. So, given a social security number, that's going to determine the name. Given the project number, I needed to give me the project name and the project location. Given a social security number and a project number is going to drive hours. Right? So, what are you really looking at here? Functionality of, in this case, keys. Right? So, what do we know about social security number? That's telling us unique identifier for an employee. So, every piece of data that is going to be in the employee row should be based off of the social security number. The things that we have in the project relation should all be based off of the project number, right? So, in other words, all of the non-primary key attributes should be dependent on the, functionally dependent on the primary key. Okay. So that's all they're really saying in here, right? Is any key functionally determine all of the attributes. And since the primary keys are unique, that's going to make unique instances across, so we should not have any of the redundant data. Okay. So lots of words to say that. Right, so we want to look and say that in order to define the functional dependencies, we need to understand the meaning of the attributes. Wait, where do we know the meaning from? The data dictionary tells us all the meanings. It's going to tell us what it's dependent on. It's going to tell us how do we get to it, right? So all of that stuff is, once it's defined, you're ready to go. Okay? So, given the instance or population of a relation, right, you can conclude that a functional dependency exists between certain attributes. If it's not with the primary key, we have a problem. So, normalization is a process of looking at our functional dependencies and say, do we have problems? And if we do, correct them before you go off and build it. Right? So note that given the state of the teach relation that we can say that we have functional dependency. So the text is associated with a course may exist. However, the teacher to a course, the teacher to a text, and course to a text are ruled out. Right? So again, you're looking at the data that you have and say, what dependencies do I have and what adjustments do I have to make associated with that? Okay, so what's all of that verbiage at the top really saying?
The book depends on the class.
Right, so, right. The text and the course are kind of tied together, but does the teacher associated with the course or teacher to a text?
Teacher teaches.
Right.
The course is in this text.
Okay. So, again, this is, you can make an argument on this that they are completely wrong in their statement. You have to understand all of the pieces behind it. So yes, they're making a blanket statement. In general, under specific conditions, what they have is correct, but I can come up with several, having gone through all of this in real life, that I would say that they are wrong. But again, it's odd cases. Okay? What about this one? Which functional dependencies may exist in this one? So let's take a look at column A and column B. What do you know about A1? It matches up to two different values in B, right? Okay. So that's probably not a functional dependency. Okay? What about C and D? Yeah, C2 is matching to two different things in D, so that's probably not. Okay, what about B and C? Right, there is, it's certainly replicated data, but there is only one set of that, so that is highlighting that that is likely a functional dependency. Okay, does that make sense? Right, when you look at it? All right, so the normal forms. I did put third normal form in this one correctly, not the third form. All right. So, normalization is the process of decomposing unsatisfactory bad relations by breaking them into smaller relations. So, what's the idea here? Make more of them. Oh, nice. Okay. So, a normal form is a condition using keys and functional dependencies to certify whether a relation is in a particular normal form. So, second, third, the Boyce-Codd normal form are based on keys and functional dependencies. The fourth normal form is based on keys, multi-value dependencies. The fifth normal form based on keys, join dependencies, right? And then none of that covers everything, so additional properties. So you have all these kind of researchers that come up with, oh, all this normalization can leave this problem still, so let's add another one. Very nice. Okay, so practical use of all this. Okay, normalization is carried out. We absolutely have to do it. Okay, okay, because again, you're trying to make it so that it works and works effectively. Okay, okay, and the further up in the numbering sequence that you get, and the additional ones that go beyond the numbers, like the Boyce-Codd and stuff, right? Sometimes people don't even have a clue what they mean or what kind of dependency problem that you have. And then, since you can't figure out what it is that you're trying to understand or detect, how do you fix it? So again, in real life, we typically do the first three, and then if there's any problems after that, we deal with it. Okay. So, data racers, like we said, go to typically third normal form, maybe Boyce-Codd, but like I said, I know a couple places that do that. I have never been in a place that has. We've always just gone to third. Fourth normal form rarely used, and that's really fourth and beyond. So, of course, we do normalization. We then do denormalization. So what happens when you denormalize something? You undo what you just did. Right? So why would we undo it? You made so many relations the database management system won't be able to function. So you break it all apart, then you combine stuff back together again. It's great. What kind of job do you have that you blow stuff up and then you put it all back together again? Maybe a city planner does that or something.
Just let it fall apart.
Yeah. All right, so definition of keys and attributes, right? So super key, right, of a relation is a set of attributes, right, as a subset of the total relation with property that no two rows, right, in any legal relation state are equal, right? So again, it's kind of making them unique, as simple as that. So a key is super key with an additional property that's removal of an attribute will cause that to not be a super key. So don't worry about this, right? So I'm not getting, they talk about all these keys being a super key, right? Concentrate on the keys that we have talked about. Primary key, secondary key, composite key, foreign key, right? Stick with those. Right? So again, we put them in here because the books talk about them. You will find them in every database class. They talk about them. In real life, we don't deal with them. Great in theory. Okay, So we talked about the candidate keys, right? So, right, they're lying to you again, right? So one of the candidate keys is arbitrarily designated to be primary key. Absolutely not, right? You have a reason that every primary key that you select is the primary key. You're not arbitrarily picking anything, right? There has to be a reason. It is the only unique key value that we have. There's only one. Oh, it's not arbitrary, it's the only one. Right? I have multiple instances where I have candidate keys that are a single value. Any one of them can be used. I'm going to select which one. The one that the customer understands and uses the most. The one that we are used to talking about. When the customer gives me a requirement to write some functionality, they're thinking about it in terms of what data that they have. I want it to match what my customer is thinking about. Right? So I'm not arbitrarily picking anything. I am picking things that make the most sense. Okay? And again, they talk about others as being secondary keys. There's usually a subset of the secondary keys that also are the search keys. Right? I talk about it the other way around. Right? My candidate keys may or may not be search keys. I can have search keys that are outside of the candidate keys. So again, every place I have ever worked, we have talked about secondary keys as being keys that we use to search on a routine basis. So books talk about it this way, the reality talks about it differently. Okay, a prime attribute must be a member of some candidate key. Okay, a non-prime attribute is not a prime attribute. Wow, that's pretty high tech. A non-prime attribute is not a prime attribute. So I would guess a prime attribute is a prime attribute. Ooh, okay. Don't worry, that costs you an extra $50 in your cost of your textbooks or that kind of stuff. Okay. Okay, simple. This is really, really simple. Even the book talks about all kind of stuff. Right? First normal form just says get rid of any redundant data. Simple as that. If you have redundant data, you need to split it out because how many instances of data do you want? One. So, yeah, look, do I have redundant data? Yes. Break it apart. Simple as that. So at the end, when you say your set of tables or your databases are in first normal form, that means I can look at all of the rows that I've laid out and there is going to be 0 redundant data. So yeah, they talk about all this stuff, but that's the bottom line. Okay. All right, so what do we have here? Right. So when we look at this, right, we have to break things apart because what do we have in here? You can have duplicate data down here in a department with the location, for example, right? So again, you're looking for what kind of things do you have with redundancy and where can I break it apart? Okay. Right? So what do we know about our department down here at the bottom? They got multiple locations that are the same, right? Okay. I could have the department manager that's the same, right? So again, you're looking and saying, some of this data is redundant, but it needs to be. And there's some that I can completely eliminate because I only need one instance of that. But again, we typically automatically start with things in first normal form because we're pretty adept at not having redundant data if we plan it right. Okay, so again, here's just another example of it. So what do we know in this case? If I'm going to have these instances, right? So if we look at John Smith up here, in their social security number, I have to have two instances of that same data because I have two different project numbers with two different sets of hours. So even though they list it once, I see multiple lines. And if I fill out that entire table to make all of it, I'm going to have redundant data. So a lot of times, the customer will hand you something like this and you go, nah. Right? I just know from looking at this, it's got redundant data and I'm not going to build it that way. Like I said, if you do it right, your ERD is typically already going to be in first normal form. You don't have to worry about it. All right. Okay, second normal form. This is really easy as well. Right? So what this says is that if I have an attribute, it needs to apply to the entire primary key. So in our instance here, right, the social security number and the employee last name, well, given that, I should be able to get the full thing, right? Okay, if I have you as a student taking a course, so I have the course number, and I have the course name. What's that tell you? You took a course, but course name doesn't apply to you, it only applies to the course number, so it's only partially dependent on the full key. So therefore, I'm violating the second normal form. Right? So, given the key, whether it's, right, it's pretty easy when you only have one, right? Is every single field totally functionally dependent on that key? If it's not, you need to pull it up. So, second normal form issues typically come with composite keys. Is that non-key attribute apply to only the combination? Right? So again, what about you taking a course and a grade? That grade is associated with you and that course. It uniquely applies to both. You taking a course and the course name isn't dependent on you, it's only dependent on the course number. You taking a course that has got 3 credit hours, that's not dependent on the whole thing either, right? Because credit hours isn't dependent on you. You taking a course in your name. Your student ID number is the only thing associated with that name, right? So look at every non-key attribute, look at the entire key and say, Do I need that full key to get that piece of data? If you do, you're fine. If you don't, you need to break it apart. That attribute needs to go someplace else. Okay?
So in this instance, what will go? So for example, you mentioned about the student and the course name.
Right, so I should have a course instance
Yeah.
that is going to be identified by having a unique course ID and have the course name associated with that,
So it's
right?
going to be another relationship.
Yeah. So a lot of times, right, either we have it on the wrong relationship or we have to build a completely new one. So you're absolutely correct on that.
Okay, so for example, student should not have a course name on the table, the student table, you should not have a course name, but you can have a course ID. How it works.
Right, so if you think back, right, so if I have a student taking a course, right, so I have your student ID number and I have the database course. Okay. And I come and say, okay, so now I have your name, your address, right, and what department that you are enrolled in, and what degree you're going for. Okay. And then I have database systems, and I say it's worth 3 credit hours, and here's the, it's called database systems, and right, I have all the data about that.
Right.
But, okay, and I don't have anything else related to a student or a course anywhere. Okay. I would look at this and first off, I would look and say, gee, I have a whole bunch of redundant data in here because I would have your name and address and stuff for every single course that you ever took.
Okay.
So I should have eliminated that in the first normal form.
Right.
Right? And I should say, oh, looking at this redundant data, I need to pull it out and put it into a student relation. Oh, look, for every student that took the database course, I have the course name, course description, credit hours, and all that, so I have duplicate data again. So in first normal form, I should be creating a course. Right? Now, if there's any other data that I missed in deriving that, I should now pick it up in this one. Right? So if I missed it by chance, this is the second check to say, okay, is the relation I ended up with, is all the non-primary key data totally functionally dependent on the combination? If it's not, I have to move it somewhere. And it's typically going to be related to one of the two, or 3, or whatever you have. Okay? If not, I have to create a separate new relation associated with that. Okay, does that make sense? Yep. Okay. Okay, so second normal form, simple. Totally functionally dependent on the entire primary key. Okay. Okay, so the third normal form, again, so this is simple. You're looking for embedded tables. Just think about it that way. Okay? So, I could have a instance where I say that inside I have a, right, so in the employee record I have the department code they work for and the department name they work for. Do they need both of those? No, right? But both of those are related even though they're not part of the primary key, they're not a foreign key, but they're related. Again, I should probably have caught this in the first normal form creation, but if I didn't catch it there, the third normal form is saying, for the non-primary key data, do I have 2 or more pieces of data that represent exactly the same thing? And if they do, I need to pull them out. And I leave 1 behind, that is going to be the foreign key into the new relation. Okay. So, very simply, first normal form, eliminate redundant data. Second normal form, is fully functionally dependent on the entire primary key. Third normal form, get rid of any embedded tables. You do that, you'll be really close and you go for it. And with that, I think you should go for it and head for home. Okay.
What kind of exam is it, cumulative? So everything from the first exam and this?
So the exam, which is when? 2 weeks, right? So for the exam, right, it is, the questions are going to be based off of the topics that we have covered since the midterm, but this is all based on all the other stuff, right? So yes, there could be some question that is going to, so if we talked about something again, right? So we talked today a lot about the ERD, right? So I should be able to ask you about the ERDs, the way that they're written, right? Because we talked about the unions and we showed examples of it, right? The complete and the build and why you do those, right? So I'm not going to, for example, ask you to draw another ERD, right? So you've already done that. I'm not going to ask that again. But the concept of ERD and the things about it, you have to be able to describe what we've talked about before and what we talked about since. So, long and short of it, I can't exclude and say there's going to be nothing, but I'm going to look from the topics that we have talked about, and that is going to be what I'm going to concentrate on, and yes, it could overflow into data or answers that you have to be based off of some of the things we talked about before. So, it depends. But concentrate on the stuff since. And you'll be fine. All right, so Cooper, I have to put out the evaluation form. I need to identify for you a list of all of the things to put in your presentation and stuff, and then kind of a write-up for what I'm expecting to be coming with this one. And again, right, whether you're ahead or behind of where I'm laying out some stuff, right, it's okay, unless you're really behind. Okay? All right. Have a great night. Have a great week.